Hello, hello. This is Fridays, 4 p.m. here in Berlin. My name is Juraci Pachankroling. I'm a software engineer, and I've been doing telemetry systems since 2015. This is Telemetry Drops. This is a sister project of Dose de Telemetria. So Dose de Telemetria is a project that I started a few years ago, I think a little bit more than 3 years now, where I share every Friday for half an hour some content about observability, telemetry, monitoring, or OpenTelemetry, more specifically OpenTelemetry. OpenTelemetry is where I'm more comfortable with. I've been doing OpenTelemetry since the very beginning, since 2019. And here I share a lot of content about OpenTelemetry, specifically about OpenTelemetry with you. From time to time, we are going to cover something about observability, about monitoring, although those topics, they are covered elsewhere as well, right? So we are trying to focus here on deep technical content about OpenTelemetry, and this is what you find the most here. For those who know us from Dose de Telemetria, you know how it works. If you are new here, here's a few words about this project. First of all, this is a personal project. It's me. It is not. I'm not trying to sell you anything here. It is independent from any vendors. You are not going to see specific solutions about specific vendors here. The knowledge that you get here is vendor neutral knowledge, meaning you can apply this knowledge with OpenTelemetry across all of the vendors out there. All right, so there might be some quirks, and I blame your vendor if there are quirks, but the idea really is focusing on OpenTelemetry, focusing on being vendor neutral, right? So not being a lead to something here. Perhaps the only thing that I'd like you to pay attention to sometimes, from time to time, is that if you are interested in getting more structured content, something that goes deeper into specific topics, then take a look at telemetrydrops.com. There's a course that we are offering there. We have this content in Portuguese ready, 100% ready. It's available there. So if you speak Portuguese, just go there, dosedetelemetria.com, dosedetelemetria.com. But if you speak English, then go to telemetrydrops.com. It's not all of the content is ready. We are starting to produce the content in English. We have a few lessons ready. A few other lessons are in the queue to be produced. And because of that, we have an early bird right now, right? So go there, secure our early bird. And over the next 4 months, we're going to deliver the whole content there, the whole syllabus based on what we have in Portuguese. All right. We are having a few things extra for Telemetry Drops compared to Dose de Telemetria. So if you have a trilha de OpenTelemetry with Dose de Telemetria, you have access to Telemetry Drops in English as well. If you're joining during the early bird, then you have an extra gift for you. So if you are part of Telemetry Drops, just join the course there, and you're going to find an OTTL reference guide for you. All right, so if you want a reference guide for OTTL, OpenTelemetry Transformation Language, join Telemetry Drops, and we're going to send you this quick reference guide, a PDF containing the basic information that you need to know about OTTL. Now, the topic for today is OpenTelemetry, TLS, security collectors, telemetry, secure pipelines. That's it, all right? So we are talking about secure pipelines today. We are going to talk about what is a pipeline for me, what do I see as the pipeline, and what are the points where we have to secure the pipeline, and then we dive deep into securing a specific collector pipeline. Okay, so we are going to see how we can configure OpenTelemetry Collector with Keycloak. Keycloak is going to do the authentication for us between two collectors. We have one agent collector, one remote collector, and we're going to ensure that the agent collector sends OIDC or OAuth data, sends a bearer token, a valid bearer token to the server, to the remote collector, and that remote collector validates this token. So we're going to see in details how it all works, and we're going to configure TLS for that communication as well. All right, so I don't know how long it's going to take. All right, so I think it's going to take perhaps half an hour or so. That's the goal. If it takes longer, it will take longer, and if it takes shorter, then it takes shorter. This comes from Dose de Telemetria. We don't have a strong commitments here. We don't have a schedule to fit in either for on the lower boundary or the upper boundary. We just do something here. All right. I'm not quite sure that everything is going to work out, but hopefully it will. And this is also part of the idea of Dosage Telemetry. I just come in here, open a webcam, we do something together, and then if it doesn't work, then it doesn't work. It's just, it is the real world. Leave your comments here. So if you have any specific comments, if anything is not clear, leave a comment here. And before I go into the actual content, just one more thing. Click on follow this page on LinkedIn, or subscribe to this channel on YouTube. It's the very beginning of Telemetry Drops, right? So we need a little bit more subscribers, a little bit more followers, so that we can unlock a few extra features. This week, we are able to live stream this on LinkedIn as well. So if you're watching through LinkedIn, then it's possible this week because you are following this page. So we needed 150, I think, followers for the page, and we just got this number this week. All right. So this is the first time that we are live streaming on LinkedIn. And perhaps a last word before we actually start the content is, I share my time of like this. I share the Fridays between Telemetry Drops and Dosage Telemetry, meaning we have a live stream every couple of weeks for each one of those projects. So this week is Telemetry Drops. Next week it is Dosage Telemetry. So next week is in Portuguese. If you speak Portuguese, then you are on a good spot. You are at advantage because you have a new live every week, and they are different topics. So we have different things at Dosage Telemetry, a few things that we've done for Dosage Telemetry we are covering now here at Telemetry Drops as well. Cool. All right, so let's get started. Finally, so what is a telemetry pipeline? Let's start by the very beginning. What is a telemetry pipeline? If you look at what other people are talking, I mean, several people are talking about telemetry pipelines nowadays. Each one of them apparently have their own definition. So I'll have my take on it as well. So telemetry pipeline for me is the whole pipeline, right? So it's the whole situation between generating a telemetry data at your application and the data being received by your backend. So the moment that you become responsible for that telemetry data is the beginning of your pipeline, and the end of when you hand off this telemetry to somebody else, that's the end of your pipeline. And everything that is being in between is your pipeline. So let's draw that a little bit here using Excalibur. All right, so let me move the screen to the other side here, and let's see if it works. Cool, it works. No, it doesn't that much. Okay, okay, there you go. Cool. Let me see if I can be, okay, cool, that kind of works. All right, so what is a telemetry pipeline for me? A telemetry pipeline, so we have here our microservices, so we have here the payments service, and let me increase here the font a little bit, so we have here the payments. Let me remove the word service, and in that service, we have the OpenTelemetry OTel SDK. All right, so we have the API, and then the API eventually calls SDK, and the SDK actually generates the data, and then that data goes to a collector somewhere. Right, so it might be an agent, it might be a remote collector. So this is a collector. Perhaps we have other collectors in here, so perhaps a lot of them, one after the other. Of course, the more the merrier, right? No, I'm kidding. And then here we have the backend. There you go. So here is the backend. So I joked a little bit that we have a lot of collectors in here, but it represents the real world, right? So in here, in some situations, you would have a very small collector here. Let's make it very, very, very small. So this collector here would be like a sidecar or a daemon set or something that is running here very, 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 very close to our workload. So this is the very beginning of our pipeline. So the OpenTelemetry SDK generates this. All right. So this here is the beginning of the pipeline. So this is the very beginning of our pipeline. Let me get this here a little bit. And then our collector, let's put the pipeline with a different color here, shall we? Which color should we use? I like this color. Okay, so that color, this is now the color for our pipeline. Let's something like this. So it's prettier. So this is our pipeline, and then we might. So I mentioned we have a lot of collectors in between, and what it means is in the real world we have a lot of layers of collectors. So we might have a collector in here, and that collector calls out a collector in here. Perhaps this is a collector in one cluster. This is a central collector that is managed by the central observability team, and perhaps there is another collector there for the security team. And at the same time, this one here sends to the backend, right? So whatever is in purple here is our pipeline. So we are responsible for the whole pipeline, and it starts here at the between the SDK and the first collector, and it ends here where we delegate. Oh, so actually this other collector here. So let's say this is our observability backend. Let's make it smaller. Cool. Let's make it closer, and in here we have our, I don't know, our security backend, whatever that means, right? And in here we have, like, from this we have here, right? So all that is in purple here is our pipeline, is part of our pipeline. And our focus here today is how can we secure this pipeline? So what are the things that we have to think about when securing this pipeline? And there are quite a few things to think about. So the very first thing that we have to think about is one of the questions that I got when I first got when working on Jaeger. So I was a Jaeger maintainer a few years ago, and I was at a conference, and somebody came to me and said, you know what, I need to ensure that the data that is being generated by my payments service is not tampered with, like it's not changed midway between the payment service and the backend, because I want to make sure that when payments says that something happened, I need to ensure, I need to be certain that it actually happened, right? So, and when I see that something didn't happen, like if I'm not seeing something, then I have to have the assurance that things did not happen. Like if I don't see a span that represents a user deleting something, then it means that the user did not delete something, right? So that's what they wanted. How do we do that? So how do we ensure that something that we don't see didn't happen? It's quite impossible for the telemetry systems that we have today, because one of the main thoughts behind telemetry systems is we should not affect the system that we are observing, right? So the act of observing a system should have very little overhead. Of course, we are paying some penalty, we are paying some resources for that feature, but we should not negatively affect the application in meaningful ways. What it means is if I'm not able to capture an action and send this data out, I should not fail the application. And if that's the case, then if a user did something and we failed to report that, then we should not fail the application. So that means we cannot trust what is not in there. We can trust what is in there, perhaps, right? And what can we do to trust the data that is there? One answer to that is on our payments, we can store a CRC, or we can store a hash of the attributes that we are saving to the payments. So what we can do here is we can add a set of attributes. Let's say this is a user.id 123. Let's make it another color. I like this color here as well. So this is a user blah, 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 and then org ID is 456, and the action that the user took was, I don't know, action was delete something, right? So delete. All right, so what we can do is we can take this record like this, and then we can hash those attributes. And once we hash that, we can store the value action hash, I don't know. Then we have ABC123, right? And that becomes an attribute in our spans. So when we create a new span, we can store the action hash. Now, this is handled by our application. There is nothing that we can take out of the box to do that for us. But it's very easy to do, right? So whatever hashing mechanism that you use in your application, you can use to calculate this hash. All that you do is you get a well-known set of attributes like this. What you can also do is you can add what are the fields that you use in the hashing. I don't like that. I like a specification like hashing, hash version, for instance, would be one, and then you store on a database somewhere, the version of the hashing, the version 1 of the hashing included user ID, org ID, and action, and that's it. Now, what happens is when you are at your backend, you could have a tool that provides you what is the hashing for that specific record, and then you can match the hashing. Right. So this is one way of doing auditing. Is that doable? Is that feasible? I mean, doable it is, right? But is it feasible to do all of those hashings for all of the necessary actions in there? That's a question for you to answer. This is one way of doing things. This is one way of doing things with OpenTelemetry, with telemetry systems. You don't have to do that with OTel, right? So OTel was not made for that, but you can abuse OTel, or you can abuse your telemetry systems to do that. You need some tooling around it. So you need tooling to hash it at the source, and you need tooling that you have to provide to your users when they are using your observability backend to verify the hash. It's possible, right? So of course, instead of sending data to your observability backend, you could also be sending data to your observability backend plus to a specific service of yours. And this here could be, let's make the same format as the observability backend. This is your verification backend. All right, so what you can do is at this verification backend, you can take either a sample or all of your telemetry data, and then the whole purpose of this backend would be to verify that data. And whenever you find something that is not a match, then you raise an alarm. Then you raise a flag and say, I found a mismatch. There's something funky going on in here. Take a look. That means take a look at that. See what's going on. Right. So this is one way of doing things. I'm getting that out before we get into the more concrete things, because that's a topic that people ask me over and over. Is it possible to do? It is. It is possible to do. I've seen it done once or twice. But I think I would definitely look into other mechanisms to do auditing instead of this one. Again, doable and easy to do if you own the whole generation of data, and if you are able to do this verification backend. But certainly there are less complicated options out there. Cool. What are the other things that we can do to secure our pipeline? So we are securing the data in the pipeline with this approach, right? So we are making sure that the data that is in there is secure, is not tampered with. This is one of the dimensions of security, is ensuring that the data that we are seeing is accurate, is real, is the data that the user communicated to us. All right. So that's one thing. The second thing is, how do we ensure that the data that this collector is sending to this other collector is secure? Like, is the pipe secure? Is the communication between them not being tampered with, and so on and so forth? TLS offers us a good way of securing that pipeline. All right, so let's implement TLS between one collector and another collector. Let me open my OTel collector cookbook. Let's see if you are seeing what I'm showing. Yes, you are. Cool. All right. So this is, let me open a TLS. Where is it? TLS. All right. So this is a TLS cookbook from the OTel cookbook. I think I've shown you before in a previous live. This is the OTel cookbook GitHub repository. It is within my own account on GitHub. So this is github.com/jpcrawling/OTelcall-cookbook. Yes. And on this recipe, we have two collectors. One is an insecure endpoint. So this would be the local agent, or like a sidecar or a daemon set. And we have a remote collector. In our scenario here, this is the insecure collector. All right, so this is insecure. Let me change colors. Let me make it perhaps red for insecure. We don't have red. Let's make it orange. Cool. So this is insecure, and this one here is secure. All right, so this is the secure collector, and this is the insecure collector. So this communication here between the SDK and the first collector is not secured by TLS. It could, but in this case here, it's not. And then the second hop is between this collector and this collector. So this pipe here has TLS in it. Let's change the color. So we have TLS. Oh, there you go. Cool. And how do we do that? It's easy. So what we need is, of course, you need certificates, right? So you need TLS certificates. In production, you'd likely use a proper signed certificate by a reputable, or a CA, by a reputable certificate authority. But in our case, we're going to use CFSSL to first generate a CA, to generate a certificate authority, and then we're going to use that CA to sign CSRs. So a CSR is a certificate signing request, if I'm not mistaken. So the first part is going to request a certificate. The second part is requesting the second certificate. All right, so we are going to have a certificate, and then this one here, the insecure, is going to trust the CA, and the CA signs the certificate for the server. That means if I trust the CA and the CA signed that certificate, then I trust that certificate, right? So that's how TLS works. So what we're going to do here is we have a CA CSR. So this is a CSR is a certificate signing request for the CA. So we have here the hotel collector CA, some information here. I like CFSSL to generate my certificates. I think it's easy, but you just do you, right? So you do whatever you think it's easier for you to generate your TLSs. It is easy, right? So I think that's the main key takeaway here, is that it's easy. So how do we do that? So I have a few commands here that I can just copy and paste. So we sign we generate the CA, so the CA.pem, and then we generate the client certificate, and then we generate the server certificate. There you go. Cool. All right. So we have now all of the certificates, and if I list the files in here, we have today is September 5th, so we have the new files in here, right? Cool. All right. Now, how do we do? What do we do? We now run the collector. So we run. So, folks, let's take a few moments, a few seconds here to take a deep breath and prepare for this configuration. OpenTelemetry Collector is very flexible. It's very versatile. What we're going to do here is we're going to configure several pipelines within a single collector service. All right. So what we're going to do here is we have a service, we have a set of pipelines, and we have a pipeline for traces, another pipeline for traces, and one pipeline is the pipeline called insecure to secure. So here we have the OTLP receiver, and we are exporting to an exporter named OTLP/secure. And then on the secure pipeline, we have the traces secured to backend, and then we have a receiver that is secured, and then we export to the OTLP HTTP backend. Right. So this is how it works. Let me show you the configs for that. So the receiver, plain receivers, HTTP and gRPC 4318 and 4317. We can remove that. And then another receiver. We can also remove the HTTP. Let's only leave the gRPC to make things a little bit simpler. And then here we are sending data to an OTLP backend, OTLP HTTP backend. And we could also even actually use another pipeline. Anyway, let's not make it more complicated than it already is. So what it means is in this collector, we have two pipelines, or two sets of pipelines. Let's remove the metrics pipelines. Let's make it even simpler. All right, so we have here only two pipelines. The first pipeline is insecure. It opens a port 4318 or 4317 for a gRPC, exposes that port to the public, and then it receives data, and then it makes a connection to the gRPC on 5317, and that communication is now secure. Right, so we have everything running in one process. That's the beauty of the collector. We can simulate production scenarios with one collector alone. Cool. All right, so let's see. I will change this one here from this to debug, and then we change here to debug. All right, so just to make things a little bit easier. Cool. So we have OTLP secure, and then OTLP secure to debug. All right, let's see if it works. I didn't test this one here in a while. So we have OTLP receiver, OTLP secure receiver, and OTLP secure receiver. Now we expose TLS. All right, so we that's it. And then on the exporter side, when we are sending data to the server, we specify the CA file as well. And then the endpoint is 5317, and this is the receiver. I think it should work. Let's try it out. And then in here, we change it to 4318. I think I have something running on 4318 to receive my telemetry. Let's change here to 15 seconds. And let's change, that's it. Cool. All right. Let's see if it works. So hotel call config, and then hotel calls. All right. It's actually working, right? So what we can do now is we can start a new terminal and do a telemetry gen, sending insecure data to 4317. So insecure traces 4317. And what we should be seeing is we should see data at the secure to backend pipe. So if we see anything on the console, then we know that it works, right? So there you go. And we go here to ours, and then we see here that it works, right? So it's failing to send data to a backend, but that's fine. But we see that it did receive 2 spans, and it received 2 spans on the service hotel called TLS, and the component ID is debug, right? So the debug exporter, this one here, is seeing 2 spans coming in. So we have a TLS communication happening between the 2 pipelines. And all right, so this is TLS, right? So we secured the pipeline. We configured this one here. You've seen it's easy. It's easy to generate TLS certificates, and it's easy to configure a client sending data to a server via TLS. There is no reason not to do that, right? So just do it. Don't do insecure. Do secure. All right, cool. So that's one way of doing things. This is half the story. Now, the second half of the story is, how do I ensure that my collector and my agent and my collectors, they are, how do I ensure that my agent is trusted by my collector? Of course, one way is doing the certificates that we've done. But doing MTLS, which is what we've done, so mutual TLS, is kind of okay, right? But it's kind of hard. I mean, the initial setup is easy, but then rotating the certs over time and so on and so forth, that's kind of a rumor. But what we can do here is the authentication of the request. So we can leave the TLS for the securing the pipe, but then what we can do is we can do OAuth, or we can do OIDC or OpenID Connect between the 2 collectors. And what we can do is the collector does not need to know the remote collector does not need to know the local agent or the local collector. The way that it works here is, let's remove this part here. What we can do here is we can add a key cloak close to this one. Let's add a key cloak in a different color. Let's add this one, and with a like this backend. Okay, cool. That's this background color. So this is our key cloak, and what's going to happen here is, let me do a key cloak here. All right, so we're going to add key cloak to the picture, and the way that it's going to work is this collector is configured to say, I trust the keys that are issued by this collector, this key cloak here. All right, so we configure the collector to say, go get the certificate, the public certificate from Keycloak. And whenever I receive a JWT, so a signed token, I know the key, I know the public part of the certificate, so I can match, I can verify the token without having to talk to Keycloak. Right, so at the very beginning, I talk to Keycloak, I get the certificates, and then whenever I receive a new key, I match the signature of the key with the public key, with the public part of the certificate that I received from Keycloak. And this one here, what it does is, at the very beginning, it goes to Keycloak and says, I'm the client agent, and here's my secret key. Keycloak does like, this is now your access token, or this is your I think it is an access token first, access token, and then the agent uses this access token, which has a certain validity, so it's valid for some time, and then it exchanges the is that the access token or ID token? I forgot. Anyway, based on an initial token, it exchanges by another token, and that is the bearer token that it sends to our collector in here. All right, so let's actually change. So the pipeline is this one here in purple. So we have TLS, and what we have is in our HTTP message, in our HTTP payload, we have an authorization header with a bearer token X blah blah blah. So this is the I think it is actually the access token. I'm a little bit rusty with these folks. Anyway, so this token is received by the collector, and then the collector gets this token. Sorry, this is only the certificate, so the cert. And when this collector here, let's make some space here, shall we? Okay, cool. All right, so it's a little bit better now. All right, so this collector here, whenever it receives the access token, it matches with the signature from Keycloak. If Keycloak is out, that's fine. We cache the public part of the certificate. It verifies out of band, like it doesn't need to talk to Keycloak to verify the token. The token is signed, so we can verify the signature. Is it okay? It's okay, so it can move along. So it can move on. It can move on. I can receive this data. I can process this data. All right, so let's see how we can do that. I don't have a Keycloak running right now. Let's start a Keycloak. So let's open a different recipe. So this new recipe I just created today for this live. So I did a preparation like 1 hour ago. And I guess it works. It's based on a blog post. I was looking at this blog post. This blog post has now almost 5 years, folks. Time flies. It's almost 5 years. I keep updating this blog post. Surprisingly, it's still very accurate. I changed only a few things over the last 5 years. The last time that I changed was on Keycloak 23. Right now we are on Keycloak 26. I tried very quickly this morning or 1 hour ago or so, and it kind of worked. So let's try it out. Let's try to follow that. I'm going to keep this guide on another screen, but I translated that guide, or I actually asked Claude Code to help me translate that into a recipe for the repository. So hopefully I'm going to commit this recipe, if it all works, later into that repository. Anyway, what do we need? A contrib, telemetry gen, CFSSL, and that's it. So let's run a Keycloak. Here is a Keycloak. We have nothing running. Cool, that's good. All right, so let's start a Keycloak. Oh, we have a Keycloak running. Now we have a Docker Keycloak. Cool. All right, so let's start a Keycloak. Oh, it's missing the RM, that's why. Okay, cool. So now we should be having a Keycloak running. In a few seconds, it should be up. Let's wait a little bit. Let's do a docker logs Keycloak. Oops, -F. All right, I think it should be there now. Okay, there you go. And then admin. Okay, that's fine. I know what I'm doing. It's just a demo. Don't complain too much. And okay, all right. So let's create a new realm. So manage realms, create a new realm. We're going to create So here we create the OpenTelemetry realm. Create. And now we have a new realm. So this is currently being selected. Let me come in here. And then within that realm, we're going to create 2 new clients. And the first client is our collector. So this is our remote collector, right? So this is not, we're going to use the terminology here, agent and collector. Agent is an OpenTelemetry collector. Yes, I know, but it stays very close to our workload. It is the sidecar or the daemon set or things that are running on the same node, on the same machine, on the same bare metal. This is, and the collector is the remote one. It's the fully fledged collector where we do some processing, we do transformation of the data, and so on and so forth. So that's the collector. Next, and then what we do here is on that collector, I think we just do that. Next. That's a simple client. We don't. So again, this is the one that acts as a server. So we don't actually do any connections between this one and another one. We only use this one to validate the connection. And what we're going to do is the client is going to include the server as the audience for the token. All right. So in OIDC, what it means is when a token is issued to the agent, it includes an audience in there. And the audience is like the collector. So the collector knows that that token was issued for that collector, right? So what it means is I don't blindly accept any JWTs that were signed by this keycloak on this realm. I only accept tokens that were issued for me, for the collector. Right, so that's the purpose. So we created this one client ID here. We created this new collector here. It's there, it's saved. We now create a new client, and this is the agent client. And on the next page, we select direct grants, and that's in the client authentication. So service account roles. Now, this is the one that we need a client secret. This is the one that is talking to Keycloak to retrieve new tokens, and it sends this new token to the collector, right? So this is the agent. Cool. Next. There you go. Credentials. We copy these credentials in here. I'm going to copy and paste already in my agent. So agent, I have an agent here. Where is the key? Oh, there you go, here. So this is a secret on my agent. So I paste the key here. It's fine. This Keycloak instance is dying soon, so it's okay for you to see this client secret here. All right, so the other configuration is here. It's very plain, simple, like client ID is agent, the token URL. This is a plain OpenID connect URL. The only thing that is different is /realm/OpenTelemetry, so it's specific to Keycloak, but everything else is following the specification. All right, so that's it. And what we can do now is, now we need to specify a client role. What we're going to do here is we go to the client scope, and we create a new client scope. And this new client scope is going to be agents. So this is a scope specific to the agents. We're going to include this in the token scope. I think this is pretty much it. There you go. All right. And then we add a new mapper, a configure new mapper audience. So what it means is for the agents tokens, we're going to add a new audience, and the audience is collector as audience. Collector as audience, and then we include the collector as the audience, and we include here. There you go. So this is the ID token that I mentioned and the access token. I don't really know what is the lightweight access token, but I probably want that there, and save. Okay, cool. So what it means is now we have this audience being added to the tokens that has this client scope. So we have a new client scope called collector as audience. What we can, agents. So in agents, we have a mapper named collector as audience. The thing that is missing now is in clients, we select the agent and we add a new client scope in here. So client scope, and we add the new scope that we generated. There you go, by default. So what it means is whenever the agent client requests a new token, the client scope agents says that I need to add the collector as audience to the token. Effectively, what it means is all the tokens are issued to this agent. They include the collector as the audience. That's it. Cool. All right, so we have TLS certificates already, so that's fine. Let's take a look at our collector configuration. So this is our agent. This is the one that is running close to our workloads. We have the client secret, we have the client ID, we have the token URL, and then it sends data. So this is, and the receiver is running on port 5317. So 5317 is the non-authenticated, is the insecure. And then it sends data to localhost on 4317, right? We have here. And then what we do here is we add an auth authenticator, and then we set OAuth to client. What it means is this authenticator, this OAuth to client, it will manage the life cycle of the bearer tokens for us, right? So whenever it starts, it goes through Keycloak, obtains a new access token. When the access token is close to being expired, it goes and refreshes the token. It gets a new token. and then that new token is sent to the collector. The other authenticator that we could have used here is the bearer token authenticator. But the bearer token authenticator, it loads only static tokens. So I have to configure that token either as a value here in my config or on an external file, and that's static. Right, so we don't want that. We want our client here to be talking to Keycloak from time to time to refresh the token. Cool. All right, and then we just create a pipeline here. So the insecure OTLP receiver sends data to the secure. Cool. All right, so let's see where we are. We are in the auth directory. So we can do is we can start the agent. But before we start the agent, let's take a look at the remote. All right, so what the remote does is it is starting an extension called OIDC auth extension. And in the server capacity, we just name it server. I think it is only a server authenticator. We say what is the issuer that we expect for our tokens. So it matches the token issuer with this value and the audience for the token, right? So we expect the token to contain the audience named collector. So if I had a farm of collectors, different layers of collectors, I could use different audiences for each layer in my setup. Right, so I ensure that the collectors that are agents, the collectors that are sidecars, they only talk to the first layer of collectors, and the first layer of collectors only talk to the second layer. And I can control that by tweaking the audience of the tokens. All right, cool. And what is the attribute to use? So it says authorization with a lowercase a. It is not pretty, but this is how it works. So the way that it does is gRPC does HTTP headers in lowercase, and HTTP does in with a capitalized, right? So here we are just overriding the default, which is capitalized, with the lowercase a, because we're only doing gRPC here. Cool. All right. So and then some TLS certification. Of course, people, please never transmit tokens in plain text. It defeats the purpose of authentication, right? So always transmit tokens via secure channels, via TLS. So please configure TLS. If there's one thing that you can take from this live here, is this, right? So never transmit tokens in plain text. Cool. And then we have the exporter. Exported debug, and that's it. All right, cool. So let's start let's auth. So let's start our server. So hotel contrib config hotel call remote. There you go. Okay, so we have our collector started. So good sign. It probably talked to Keycloak already to obtain the authentication from like the public parts of the certificates. And here is our client. Our client made a connection already. Okay, cool. Everything seems to be working. Let's make some space here for the first and for the second. What we're gonna do now is we're gonna run again our telemetry gen. We're sending. Remember that our agent is running on 5317, right? So if we run this one here, the way that it is, it should fail, and it did fail. And if we change the port to 5317, let's go back to the logs. We don't have anything there, just that the collector is failing to send the self-telemetry elsewhere. That's okay. Now 5317, on the other hand, it should work, right? So we did receive on the agent. So we received 2 spans, and if you go to the remote, we received also 2 spans. So we ensure that the communication worked. What we can do here to verify that it actually worked, so collector bogus, and let's stop this one here, start this one here. And if we send this data again, then it fails because it says, well, it should not, I don't have the right audience, right? So the other server said, I expect collector bogus and not collector, and I have only collector and account. So, and if we remove it, then so it's always good to do a negative test as well, right? So ensure that authentication is actually working. Cool. All right. So we proved that it is working. So we have here data being received and so on and so forth. Cool. All right. So let's go back here. Let me stop sharing my screen, and I can look at you again and see if you have any questions. Let me stop here my sharing. Stop screen sharing. All right, cool. So for the past 45 minutes, okay, so it took longer than expected. So for the past 45 minutes, we've seen all the things that we have to know about the security of our pipelines. We started by talking about how to do some auditing, right? So what are the options in doing auditing of the telemetry that is flowing through our pipelines? We've seen that we can do some basic checksums. We can add a hash of a specific attributes and store that as an attribute itself. We could have done that auditing in a collector as well, right? But then, so we could apply like OTTL in the first level of collectors to do the auditing aspects of the pipeline for us. Now, then we focused on the securing the pipeline, the communication between the components of the pipelines, like an agent to a collector. We've done it first by using TLS, and then we employed authentication using OAuth authentication there. We configured a key cloak with production quality configuration. You can use that configuration in production. Of course, you have to change a few things, like minimal things, like perhaps just the names of things, and apply to your key cloak in production. But the settings themselves, they are very tight. They are the way that it should be done. I don't like demos and tutorials that show how not to do things in production. I like things like how should you do in production. And we wrap it up by showing you the demo of how it all works, right? So the agent getting a token, and the token being verified by the remote collector, by the collector. That's it. And our next topic is a couple of weeks. Okay, so let me make a pause here. We are going to talk about AI observability in a couple of weeks. And in a couple of weeks, I'm not doing that alone. I'm bringing 3 people here with me to talk about AI observability, right? I'm bringing here Christoph from Dynatrace to talk about AI observability. And Christoph is going to talk, he's going to share his thoughts with Cyril Tovena from Grafana and Max from Langfuse. All right, so Max Deichmann from Langfuse. So we're going to have 3 great names from the AI observability area, and have a discussion about AI observability. So what is actually AI observability? If I'm doing AI, what should I be paying attention to? So what are the things that I should be observing, and how can I observe it? And what are the challenges in observing this new type of workload? So observing backends is an old problem. We know how to do it. Observing frontend is kind of an old problem. We have ways to do that as well. But what about AI? How can we observe AI? What are the challenges? What should we do, and what should we not do, right? So those are things that we're going to cover in a couple of weeks' time. If you have questions, prepare them already and share them with me. I'll make sure to include that in the questions that I have, that I'm asking them. I'm not an expert in AI observability, and I have so many questions. I hope you join me in a couple of weeks' time as well. To make sure that you don't miss it, follow the channel here. If you're on LinkedIn, follow the page. If you're on YouTube, subscribe to the channel. That's it, folks. So see you in a couple of weeks' time.